There we go. So, oh, I know what the problem is. I've got it one level closer than I usually do. That's fine. They probably prefer it, actually. At the end of last class, before I so rudely interrupted myself, I was discussing the manner in which passwords are kept in databases. This is still very important knowledge. So, I recall that we talked about plain text. Plain text, which is the single worst way to store a password conceivable to man, except maybe like posting it on a billboard outside of a major city or something. Plain text is no security, right? We were discussing the progression of the types of ways that you can hide and secure passwords that have been implemented over the years. Spoilers, we are going to end this discussion with salting and hashing. So, we proceed from plain text to encryption. So, encryption in the same sense that packets are encrypted before they are sent out onto the network. A very important thing, a very important feature of encryption is that encryption is reversible, right? The way that encryption works, you have an input value, which is the text you're attempting to scramble. You have another input value, which is a key, right? The randomization, the scrambling occurs, you get your scrambled text, but having the scrambled text and knowing the encryption algorithm, if you have that key, you can decrypt the encrypted message, right? This is why it's appropriate for communication, because if you couldn't decrypt it, then there's no point in, you're not really communicating anything, right? You're just communicating random characters. So encryption is okay. It's definitely a step up from plain text. However, you have a single point of failure with encryption. If a hacker has possession of all of your encrypted passwords, if the hacker, reverse engineers, gets back out the encryption key, probably by testing a large number of encryption keys, you're cooked. Every password in that list is no longer protected. You can just decrypt all of them because you have the encryption key, right? Now, it can be difficult to get an encryption key, right? But it's nevertheless possible, and computers are becoming more powerful all the time. Right? Question?
What if you encrypt the encryption? Multi-layers of encryption keys.
This is better still. This is a thing that people do. But you're instead of being presented with a single point of failure, you now have 3 or 4 single values that, if known, allow you to get through. It's better, but still leaves something to be desired.
Fair enough.
Right. So, where do we step from encryption? Any guesses?
Salting?
No, that's not right.
No.
Not quite. Yes.
Hashing?
Hashing. Here. Whoop. Nice catch. So, hashing, all right? Hashing is not the same thing as encryption. This is a very, very important, if you get nothing else from this, there is a very big distinction between encryption and hashing, right? The distinction is hashing is not reversible, right? Hashing is a one-way operation. So if I have some text, and yes, So we go from encryption to hashing. If I have some text, like hello, using a hash algorithm, I still end up with my scrambled text. XWQ7Z. Whenever I produce, so this is a good example of why human beings are not really that good at random number generation. If you remember what my string was last time, it also relied quite heavily on like the second half of the alphabet with like one number thrown in, right? So we are very bad at random number generation, human beings. Computers are much better at it. But anyway, there is no key, right? There is no key. So there's no key to use to decrypt it, right? Now, this is going to get a little mathy for a moment, but I'd like to explain to you, this is kind of a prelude to data structures and algorithms as well. I'd like to explain how it is that we can't just, knowing the hash algorithm, we can't just reconstruct the original string, right? So, not all mathematical operations can be reversed, right? Addition and subtraction are complementary operations. Addition reverses subtraction, vice versa. Same thing with multiplication, division, right? Square root and to the power 2, inverse operations. Some operations do not have an inverse. Another way of saying this, during some operations, data is lost. I would like you to consider the following operation. And this, by the way, is one of the reasons that this particular operator is hammered so hard in intro courses. Consider, my stupid thing's failing. Try this one. That's even worse. What about me? Do I have markers? Oh man, it's gonna have to be the black one. Ugh! Equipment problems. There we go. X modulus, if I just shout it, that means I don't need the board, right? X mod 10. Consider the value, the output of the operation x mod 10. Right? Now let's say that we know that the value of x mod 10, actually I think the red one might be better. Slightly. No. Alright. The value of x mod 10 is 7. What was the value of x?
Could be a lot of things.
Could be a lot of things. Like what?
Like
17,
27,
27.
37.
Oh, that was my fault. Sorry. Yes. 7, 17, 27, 37, 47. There are many values of x that satisfy this equation. It's not possible to determine what the value of x was going into this, right? Modulus operators tend to feature quite heavily in hashing algorithms because this property is useful, right? So basically, it's not just this one string that hashes to that value. It's a set of strings. It's impossible for us to know which string particularly it was that generated this hash if all we see is the hash. So, this is better. This is a better state of affairs. This is superior to encryption. But this might leave you with the question, Well, if we cannot determine what the original string was that produced this hash value, how do we determine that, like how do we do password verification? Right? I'm going to use Notepad as my board. I apologize. Just problems, problems, problems. So, anybody have any ideas?
You hash the user input and password to compare it to what you have in the database.
That's right. So, it's like this is a very important thing. Although the hashing function randomizes the data, it is randomized but repeatable. Right? Very important distinction. Just because it's a random process does not mean it produces a different output every time you run it. Right? We are scrambling the string, but given the same string and the same algorithm, the string gets scrambled in the same manner each time. Yes?
If a hash value could be like several different strings though, could you then enter a password that wasn't the original password and it still work?
Technically, yes. Yes. That's another problem with the system, right? That's a problem with straight hashing. This becomes no longer a problem once we talk about salting and hashing. But so that's where we fix the problem. But it's kind of less of a problem than you may think. Although many strings might hash to the same value, we are once again in this kind of cryptographic space where the probability of two numbers sort of occurring in the same data set, which hash to the same value, is infinitesimally low. You're kind of in the same ballpark as someone randomly regenerating a session ID, right? So it's like, yes, you know. One might also say that like a vulnerability in this system is if you were to come up with, you know, if you were to reverse the hash and come up and calculate the space of strings that hash to that, probably one or maybe at most two of them are the sorts of strings people would choose to be a password, right? Not like, I am hoping that through this, I am convincing all of you to use like cryptographically secure random sequences of characters as your passwords and use a password manager because that is most secure. But I understand people, you know, maybe if 2 or 3 of you change your password behavior because of this class, I will be happy. But yeah, you're absolutely right. You can have hash value collision. That's what it's called. When you're making a hash table data structure, the collision is actually like an intended feature because your number of hash slots in a hash table is like generally like, well, definitely not infinite, right? It's as big as you want. The bigger you make your hash table, the more you speed up the algorithm, but it's a trade-off, right? And it depends on how much data you're trying to hold. So collision is something that's explicitly dealt with in the case of a hash table. Here it's an undesirable side effect, right? Make sense? That was a good question. Oh, sorry, that was my fault. So yeah, so that's how we do it, right? If we start with hello, and we hash that to, easier to do that at a keyboard, right? Imagine the scrambled string is all we have left. If we have a test string, hello, hash that again, it will hash to the same value. We can simply compare the strings to see if they're the same string, and that tells us if the passwords match. Hashing. This is definitely an improvement over straightforward encryption, right? But here, aside from the hash collision problem, here's another problem with this. You have to attack each password individually, but if any of you watched that computer file video, which I recommended, one of the things that's in that video is a guy literally just cracking passwords by trying a bunch of values, right? So you basically, we've gone from a situation where attacking one password attacks the set of passwords to attacking one password attacks only that password, but the passwords are still very attackable, right? It's still an improvement though, right? So, all right, very good. So, how do we improve from here? Well, we improve things by understanding a little bit more about how passwords are selected by users and how hashing algorithms work, right? Now, users, people, smelly humans, select bad passwords, right? Notoriously bad at selecting passwords. Like, for example, if your password is a word followed by a number followed by a punctuation mark, that's a bad password. Any password that's under probably 12 or 13 or 14 characters is a bad password. You can brute force passwords of like 8 characters, that can be very easily brute forced, right? In fact, even in the computer file video, which was done about 10 years ago, those passwords are easily brute forced. And as I've said, you know, we now have like the Titan graphics cards and stuff, and you know, like, obviously this is the type of thing you get a GPU to do, right? So yeah, if your password's under 8 characters, it's not really a password, right? There's also an interesting, there's an interesting XKCD comic which is generally true. How many people actually did watch the videos? All right. So, if you'll notice, this is actually the principle upon which a lot of modern systems are basing their password system. So, this is the way that people generally create their passwords. This is what you're taught to do. It's not your fault. You were taught to do things this way, right? And it's wrong. What you do is you select a word, right? You capitalize it in a predictable place. That is normally the first letter of the word, right? So that really only gives you like 1 bit of entropy, right? You make a few common character substitutions, right? You maybe throw a couple of things at the end, right? It's, you know what number or what symbol you throw in there, but you know it's probably a number and a symbol, right? You have produced a password that is difficult to remember and easy for a computer to break via brute force. Also via dictionary attack. Consider this password. correct horse battery staple. All right? Now, if you consider the number of words in the English lexicon, I think it's something like 500,000. Each one of those, so it's 500,000 times 500,000 times 500,000 times 500,000, right? In terms of entropy, you're already much, much better, even considering this as a dictionary attack. If you consider this as a brute force attack, right, that is like almost impossible to break, right? If you're talking a password of length like 25 or above, a straight brute force attack is going to take way too long to crack it, at least until quantum computing becomes available to hackers, right? So, that, as passwords go, is far more memorable to a human, right? Especially as, you know, you should be careful arranging them into a lexically correct sentence. You should also be careful about your word selection and attempt to choose rare words, as a dictionary attack is going to check the common words in the English language first, right? But, and also like, don't use a list online of rare English words, because like, the hackers will also have looked at that list and constructed the dictionary attack according to the list in the internet, right?
That's definitely a good idea to compose your internet, your password based on stuff you found on the internet.
Yeah, right? I mean, it's interesting, right? Because if you just Google into Google, right? Or the bloody AI chat algorithm, please generate me a, look, it's even a, generate me a password.
Isn't it kind of horrific to just ask the AI to generate a password for you?
Right? I see that Google itself isn't doing this anymore. It used to. But yeah, I'm definitely going to click on and use a password from most secure password generator. Methinks the lady doth to protest too much.
I feel slightly attacked because that's the password manager I use.
I mean, but this is the generator, right?
But it's on one password.
Ah, well, okay, I'm sorry for slightly attacking you. I'm sure, like, password managers are like, if the password generator is actually like a built-in
Yes.
for the, yeah, then that's fine, right? What you don't want to do is get it off of a website, right, like this. But, you know, real programmers write their own random number generators, random string generators. Writing a random string generator is within the capability of everyone who passed Python. So it's very easy. You just get your string of all of your characters you want in your password and randomize them. And do that a couple of times. There you have a password. You can write a password generator. You don't need this, all right? And you can make it as many characters as you want. What's usually, I think, good, if you're going to take this approach and use a password manager anyways, you should probably like max out what the allowable storage space is for the password, which I think normally, like, I've hit 32 quite a bit. People generally assume you're not going to use more than 32 characters for a password, which they don't know me very well then. But yeah, so passwords. Don't get your passwords off the internet, please. So, yes. A password of this type is inherently more secure than a password of this type. In addition, you can also do some permutations on this to make it even more secure. These permutations are things that are essentially trying to foil a dictionary attack. Random splits in the middle of words is a good one, right? Like putting an underscore in between like bat and turi, except that is still a technically correct word. Like sta and pull would be, like putting a random character right there would be a good one, right? Because you should always design all of your passwords with the assumption that they're going to be leaked to the dark web. Because this is often the case, right? You have to keep in mind the weakest link breaks the chain, right? We all have had to sign up for stupid little websites that we've only used once or twice, had to create an account, set a username and password. Why would you bother doing a good one? Because you're only going to use this site once, right? And it's precisely stupid little sites like that that get hacked. And when they get hacked, all of their username password combinations get leaked because it's probably a stupid little website that's storing their bloody passwords encrypted in just plain encryption or plain text or something like that. You don't know how they're handling their passwords on the back end, right? You have no idea how they're handling their passwords on the back end. So, it's those stupid little websites that get you. Because as soon as those credentials are leaked, what's the very next thing that they try? They try Facebook. They try Twitter. They try, your banks, the major banks. They try everything, right? Common sites with that username password combination to see if that happens to be in that bank, right? And that's why you should always have secure passwords for everything. It's, the best and most secure passwords are completely random, cryptographically secure strings and lots of characters. These are impossible to remember or even type accurately. That's why a password manager, which assists you with that, will produce the best results in terms of security. Password managers are generally pretty secure. Okay? So, all right, but all that being said, enough of that digression. Let's go back and talk about hashing, right? We are hashing bad passwords. We are assuming that this, even though Chrome will give it a little pop-up now that says, hey, are you really sure you want to use the password? That's kind of dumb, right? You must assume that people will attempt to use the word password on your website, and you can only write so many if statements, right? So, how do we protect those dumb bunnies with the password? We attempt to scramble the hash, right? Now, the interesting thing about hash values is that you can completely scramble them by just adding a few more characters to the thing you're hashing, right? It's not like you're producing results that are adjacent to each other. A very good hash function functions very much as a repeatable random number generator. The more random the hashing algorithm is, the better it is, right? So, a thing that at one point was in practice, but is no longer in practice because we have better techniques, is for the server to choose a magic word, right? You choose a string, and you append that to every password you receive, right? You know the string, right? Let's say, if my password is originally something like this, 1, 2, 3, 4, 5, right? We then append to that a string which is given by the added by the server itself. So we would be doing this in PHP. Underscore make this password better. Right? You now are hashing this thing rather than 1, 2, 3, 4, 5. This is much, much more difficult to break, right? It's no longer subject to just straight brute force attack, and yeah, maybe it's vulnerable to a dictionary attack, but you can imagine this being replaced with your own cryptographically secure string. Now it's no longer dictionary attackable either. But here's the thing, right? We're back to the same problem we had with encryption. If we crack 2 of these, notice that they have the same suffix. Where like, they're using a magic word, we now know what the magic word is, we can now crack all of the passwords, we're right back to regular normal hashing. We have no advantage over regular normal hashing, right? So it's an attempted improvement, not quite an improvement. So this leads us to salting, right? Salting, presumably called salting because of the sweet, salty tears of the hackers. Salting means generating a new cryptographically secure suffix for every single password that you generate. Right? So, this of course produces its own problem. It needs to be repeatable, right? So, the salt is stored with the hashed value in the database as part of the same string. You can think in database terminology, you'd call it a compound attribute, right? Now, in theory, this means you can like pick out what the salt is because it's in the database. Use that, So it's not by no means perfect, but there's no other way to like have a different one for every single entry. But this is what's currently done: salting and hashing. So, shall we do it in PHP then? There are 2 functions in PHP that do this. This was a long theoretical discussion. Once again, long theoretical discussion in this class that results in like 1 or 2 simple functions. Password hash and password verify. Now, once we're dealing with hashed passwords, you no longer have the ability to create correct entries in your own database. You now must go through your own registration script to add new entries, because it's impossible for you to make a hash value manually, right? Hash values must be calculated from the password, and I certainly don't want to calculate hashes by hand, do you? Probably not. So, let's see, I think we have some code we can start with in the announcements feed, right? Ta-da! Please open up XAMPP. I will say though, once your password reaches a certain size, it becomes somewhat more difficult to reliably enter. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I could do better, but, you know. Oh, come on. Staff. Oh, I see it. You're not supposed to put that in. Yeah. Ta-da! There we go. Wait, what? No. Wrong class. Get out of here. No! Microsoft! I hate you, Microsoft. I hope that Microsoft dies suffocated by its own farts. And if you think that that's a little extreme, think about all the lives they've ruined. You know? Think of oh, actually, it's already here, isn't it? Well, that's convenient. Think about all of the productive human labor that could have been done while people were waiting for Windows to update. Think about that collectively over the species. We have probably wasted millennia, like a millennium at least, collectively, waiting for Microsoft to friggin' update. That wouldn't even be that hard to hit a millennium. All right, so, opened anyway, you stupid thing. I hate you. I hate you. So, let's take a look at, do we even have a registration script? Well, that's something we need, isn't it? So let's, registration is somewhat similar to login. So let's pull login in, login in. There we go. File, save that. Register.php. Further, we'll need, let's dump our registrations form in the login page. Login view, which I think is index. Yeah, there we go. Insubordinate tray. Register. So, normally, websites will require you to enter your password twice. Does anybody realize the reason for this or the necessity of it? Why are you asked to enter your password twice when creating an account?
Verify that you are writing the password correctly. Verify that the user knows exactly what they're writing, right?
Right. It's very rare that a user will create a typo in their password twice in the exact same way. And if they do it twice in the same way, maybe it's repeatable. There. We go. So, we want to target register.php. I'm just going to leave this like this though, except I'm also going to say it's no longer saying login, it's going to say register.
You also need to close that form.
Ah, yes, thank you. There we go. Good. So, all of this is still true. However, where'd my sword go? There it is. Let's consider the state of this select query. First of all, how do we add an entry to a database? What sort of query do we use? Not select. We're adding an entry. Insert. Very good. This is actually a situation where this is my recommendation. Open up phpMyAdmin. Go to the SQL tab. You'll have to import the database. Did I leave that file in there? Nope. Okay. Gonna have to make a new database. What did I call this thing? No, don't click on Firefox. Stupid. Stupid! Connect.php. No, you stupid man. Computers! I hate computers so much. Why did I major in this? I didn't. I majored in robotics. Computers with arms. Even worse. So, social media site. That was the name of the database. Still in Latin/Swedish. There we go. Create a table. Credentials. Let's give it 3 columns. An ID, which is an auto-incrementing primary key. A username, which is a varchar of size 50. And a password, which is a varchar of size 200. Extra security. Although honestly, because we'll be storing hashed values in here, you should pick whatever the size is of the hash string that it generates. I just can't remember. I think it might be 64, but I can't remember. So, we have our table. So the way that I recommend composing your PHP queries, I don't recommend asking the bloody chatbot. This is the way. phpMyAdmin will generate for you a template for the table that you have. You just have to click on the insert button. Boop. And there you have it. Copy that and paste it into your script. Now, ID is an auto-incrementing term, so we don't need it. Value 1 and value 2 are supposed to be U and P. U and P. What have I just done?
We're exposed to that injection attack.
That's right. I have just exposed the website to an SQL injection attack. There you go. Yes. Don't ever do that. Don't ever splice the values into the string directly. That's a big bad. That will cause a big problem. SQL injection attack site. Okay? The way that you do that, using the PDO object, you put the little question marks in there. Little question marks. And then you provide those values during the execute step. The execute method will check the incoming parameters to make sure they are free from SQL injection attack. Okay? If anybody gives me an assignment that is vulnerable to SQL injection attack, I will know and I will flunk you, at least on the assignment. At the very least, nobody who lets a secure, like nobody who lets an attack through gets an A, right? So we prepare the query, we execute the query. We don't have anything to fetch here, and we don't have any like. We're not validating the session, right? So in fact, we can say something like, if not success, echo problem. Right? We're not really doing anything with the result. We just want it, like, here, take this, execute it. Right? Did it work? Yes? Great. So, shall we test this out?
Register is also spelled wrong. Register.php.
What's spelled wrong?
Register.php is the name of the file.
Register. Yeah, that'll be a problem. Okay. I've been marking like the database things, and it's like because it's SQL scripts, and I have to do it in Microsoft. I have to like take your files and change the file extension. Every single time, Microsoft is like, "Are you sure you want to change the file extension? It might make the file unusable." And I'm like, "Yes, for the 50th time, yes." Ah! Good grief. I know you can probably turn it off somewhere. Like, but I can't because it's not my computer, right? Like it's like one of those lab desk things that we have in the department office, and it's like, yeah, I don't have elevated privilege levels. I just have a regular user account. Oh, I hate Microsoft. All right. So, local host 1080 / 2025-11-12. There we go. We now have login and register. If we register Mr. Krabs password money, boop, we get nothing in particular. But if we take a look in our table, yes, I'm sure, thank you. You can see our values have been added. So far, so good, but we're not quite hashing them now, are we? So, we need to calculate the hash value and store that in the database instead of the password in plain text. We only need to modify 2 lines. Hash is equal to password hash key. Let's take a look at the documentation for this bad boy. So, notice it requires a second parameter. There's no like default value for it. And this is the hashing algorithm. It's kind of beyond the scope of this course to get into like what the differences are between the particular hashing algorithms available. For our purposes, password default is going to be good enough for us. But any further than this, and you're kind of starting to have to talk to someone who knows stuff about security, right? Who knows? Maybe that's you. That's one of you out in this crowd in the future. Maybe you become the security expert. There's good money in being a security expert these days. But it's beyond the scope of our course here. So, password default is what we're going to use. Password hash according to password default. There we go. As long as I click on that. There you go. So, at the moment it uses bcrypt, but this constant is designed to change over time as new and stronger algorithms are added to PHP. For that reason, the length of the result using this identifier can change over time. Therefore, it is recommended to store the result in a database column that can expand beyond 60 bytes. 255 would be a good choice. So that's important information too. So let me ask you all a question. Let's say you have a password database and you have encrypted everything according to password default, and then the encryption algorithm that means changes, right? What happens to the passwords that are stored in your password database? Do you think it's wise to have passwords in your password database encrypted according to two different algorithms? Probably not. It may even be difficult to tell, which ones are A and which ones are B, right? So, personally, I would recommend either never improving your version of PHP, or maybe picking one, right? Because, let's remind ourselves, can we reconstruct the user's passwords if all we have is a hash value? Can we rehash a user's password? Sorry. If somebody was going to put their hand up and answer that, but I immediately started shaking my head. The answer is no. The answer is no. You cannot rehash someone's password. To do that, you would have to reconstruct their original password from a hash, which is something we've said isn't feasible, right? You essentially have to do the hack. You have to hack someone's password as the person owning the password to reconstruct it, to rehash it. So let me ask you a question. Does your organization require you to change passwords every so often?
Yeah.
Sometimes, some of them do, right? That is your opportunity to improve the hashing, right? Your opportunity to improve the hash algorithm and use a different one or use a better one is when you are requiring your user to create a new password anyways, right? Because then you don't have to reconstruct the old one. But unless you are requiring your users to enter a new password, there's no feasible way to upgrade people's hashing, right? Make sense? So, in large organizations, if PHP versions are upgraded, they are done at specific times of year. and are designed to coincide with events like that. Right? Make sense? Any questions? All right. Yes. So, back to our code. We then have to make sure we're using the hash instead of the old password, otherwise we've done nothing. Save that up. Now let's see what happens if we re-register that same user. We didn't put the unique constraint on the username, so Mr. Krabs money. Register. And just for fun, Mr. Krabs even more money. Behold, a hash. That's what she actually looks like. You see what I mean when I say you don't want to try to have to invent one of those by hand? So, now that we're hashing, this entry will no longer work once we've set up the password verify side. So, this should now be deleted. Very good. So, that's hashing on the one side. Now, let's use that hash on the other side for verification during the login script, right? The login script is currently broken, right? Because we would be comparing a hash value to the string directly, which is of course never going to be the case unless somebody attempts to make, the hash value their password, and that hash value hashes to the same value, which is theoretically possible, but I guess that's technically possible, but I don't expect that would ever occur in nature, right? It would be intensely hilarious to have something hash to itself. So let's open up the login script. There we go. So we do have to reconsider our SQL query slightly, though. Previously, we were simply we were heavily leaning on the equality operator inside of the database itself to determine whether or not the passwords match. We now have better means, right? And remember, this is hashing and salting. We can't just rehash the value and send that to the database and have the database check, right? The salt that we generate, like if we call password hash twice on the same string, we get two different hashes because of the salt being different. In fact, why don't I demonstrate that for you? So, if we do Mr. Krabs and money, hash that a second time, put a new entry in the database for it, hash, there we go, browse, there you go. So entry number 2 and entry number 4 are the same password string that went in from us, but you'll notice these are two different hash values. This is because the salt is different, right? So every time you call password hash, you generate a new salt, right? So we can't anymore rehash the incoming password and check that in the database. We must extract the password that's stored in the database and compare it using a new function, password verify, All right? So that means, however, that we need to modify our query. Now we want to select password from credentials where username equals the stated username. We no longer need to provide password. This if statement is also going to change. So, first, we should check to make sure we didn't get 0 entries out of this. If we got 0 entries out of this, this means that the username didn't match any of those stored in the database. So there's no user with this username. It's correct to say invalid username password combination. We can check this quite easily. If count data is not equal to 1. This catches the case where we have no users with this username and also multiple users with this username. In theory, this shouldn't ever happen because ideally we would remember to put the unique constraint on the usernames, right? But, you know, it never hurts to be careful. So, good. Else. Now this is the bit where we are checking the password. The function we are looking at, password underscore verify. Let's take a look at the documentation. Password verify. Oh, here's one for it. That's an interesting one, actually. Password needs rehash. Checks if the given hash matches the given options. This function checks to see if the supplied hash implements the algorithm and options provided. If not, it is assumed that the hash needs to be rehashed. So this is a condition that you can. This is a function you could use if you're in a transition state between, you know, one hash algorithm and another. Perhaps you've decided to go from bcrypt to whatever the other one was, right? It allows you to test the hash to see if it's been hashed according to the correct hashing algorithm. And if not, then perhaps you're prompting your user to create a new one, right? But anyway, let's go back to password verify. Password verify takes two parameters: the password received from the user and the hash received from the database. User, database, user, database, user, database. It reveals a Boolean, true or false, yes or no, password verified or not verified. Make sense? Quite simple to use, as long as you don't confuse like what order you're supposed to put them in. Although that's not the sort of thing that I would deduct marks for on a test, right? Because it's like, you know, right? It's not wrong, it's just a small typo. But, you know, on a assignment, for example, I would expect you to get it right because I will have expected you to have run and tested the code. So, from the user, P. From the database, data at 0 at password. And there we go. That's all we need. We now are hashing the database. We're hashing our passwords and we're checking hashed passwords, just to verify that this works. dun da da dun da da dun dun da da dun. Well, actually, that won't work anymore. I have to make a new one because I put in that check to see if the username is unique, right? SpongeBob, I am ready. Register. There we go. There we go. Username, SpongeBob, password, I am ready. Log in. Dun da 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 dun da 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 dun. Everybody hold your breath. Ta-da! It worked. Any questions? You guys have been pretty quiet. I shouldn't say that though. I have gotten rid of some candy. Okay. So, any questions about like passwords in general? How things are supposed to work? What you should do? Yes.
How come we don't use SHA-256 for hashing?
It's old, I think. So, one of the sort of internet security is a bit of an arms race, right? Used to be that you could make do with just one hash, right? Now you're like a hash actually means you're doing multiple layers of independent hashing algorithms applied in sequence, right? Yeah, it just like this is why, you know, you shouldn't even necessarily listen to what I'm saying with respect to what hash algorithm you should use. What you should do is you should look up a recent, you know, good authoritative source, not ChatGPT, about whatever language and whatever system you're using, and see what the current state of the art is in terms of hashing algorithms for that system, and that's what you should use. Yeah. So, yeah, you know, hash algorithms get old and out of date, and they need to be replaced with new ones. Did I already throw candy at you? Yeah, okay. Would you like another one? People aren't actually eating it, they're just kind of, I'm going to find a whole pile of them in the garbage on the way out. Nobody likes rockets? I have, like, rockets are the thing I have left over. Who likes rockets? Okay, who doesn't like rockets? Okay, you're outvoted. I have some candy left over, and if it's still here at the end of class, I'll be very disappointed. All right. Well, I guess we can close off that topic then. Thus ends databases, the topic. Congratulations. Yeah. So we now move to MVC architecture. I stole with permission some slides from another course because we didn't really cover MVC. That like there wasn't much in the modules on the subject, but it's a very important topic. So we're going to talk about MVC now. What? Slides? That's right, slides by gum. All of this is with an extreme degree of gratitude to Dr. Kevin Brown, who wrote wrote these slides. Thank you, Kevin. We love you, Kevin. So, it's a kind of interesting. Actually, like, even during the POS committee meeting, it came up that, like, in order to be a web developer these days, like, the domain of knowledge which you need to have a working knowledge of has expanded to such a degree that, like, it's becoming infeasible to squeeze it all in before your co-op type thing. You know, like, it's every couple of years there's a new big framework, and you're not exactly expected to forget the old ones, you know? It's complex. Web development is very complex, right? Even like the web stack that we've been talking about so far is fairly complex, right? Like, just on the client side, we're having to worry about CSS, JavaScript, and HTML. But we also need to know how DOM manipulation works. And occasionally we need to know XML. I would add JSON to that, right? We communicate via HTTP with PHP. PHP, as we are finding out during the course of this course, is fairly complicated itself as well. It's talking to databases, the file system. It's talking to its session database, right? We need some architectural help, right? I'm sure you guys have noticed that, like, the assignments have been getting more and more complicated. They're becoming more and more to manage, right? Just in terms of the number of files being passed around, just in terms of, like, you know, modularization is starting to break down on us, right? We need help, right? Like, this file level modularity, a file is a function, only gets you so far. It's not up to the task of modern web application development. So, this is a talk about model view controller architecture. Right? Model view controller architecture is the thing that we've been kind of doing the breadcrumbs for throughout Java. We were leaving a breadcrumb trail for this topic. You guys remember that the assignments in Java kind of lean a bit heavily on the difference between a model and a view, right? So here and now, we are adding the third component to complete the trifecta of MVC architecture, and that is the controller. We also need to discuss what a view means in the context of a web application. You guys want a spoiler? It's all the client-side stuff. Client-side stuff is the view, right? Even if it's JavaScript, it's considered part of the view, right? The model is in PHP, but it's not just PHP. Like, it's not all of the PHP. The controller is also PHP. So, you know, model, view, and controller all have their representations inside of PHP, but, you know, we might be using PHP to insert some information into an HTML document, but, like, the view is mostly an HTML document, right? The controller, though, is pure PHP, and the model is generally pure PHP as well. So let's talk a little bit about how this gets divided. Design patterns are well-defined solutions we can apply to known problems. Typically, we split a problem up into logical subcomponents and define how those subcomponents interact together. There are several benefits to working this way. We allow developers to work independently on different subcomponents. This is especially important if you're on a large team and if you're working with like a repository system. if different people get to work on different things, it minimizes the number of conflicts, right? The number of merge conflicts. Minimizing merge conflict, conflict is inevitable, but we should try to minimize the amount of conflict that exists in our lives. This is good advice for programming and good advice for life. It also provides a common standard to communicate about problem solutions and software architectures. As you progress as a programmer, you will increasingly encounter and work with design patterns. MVC is perhaps the most widely used one. So, it's generally, probably well understood that you can't do your intro Python course and then go get a job with that, right? The way that things have been moving for, the last decade or two, even leaving aside the bloody chat algorithm, right? Less and less are you sort of working in the primary artifacts of the programming language. More and more, you're configuring pre-built design components, right? This is what a framework is, right? A framework is a series of pre-built components which you use to build the application, right? This is fine. This is good and natural, right? This is, in fact, the same process that has been iterating through the history of this discipline. This is what brought us from punch cards to things with screens. This is what brought us from working in assembly languages to compiled languages. This is what brought us from command line interfaces and compiled languages to things with GUIs, right? Things are supposed to get easier as we go along, and therefore more is expected of us as things, as the grunt work is taken out of the job, right? There's always a trade-off. As with all things, there's a trade-off. Normally, the trade-off is optimization, right? You are completely and wholly dependent on how well the framework is optimized, but normally the people optimizing frameworks are better at optimizing things than you are, right? So, trade-offs. So, the model view controller distinction, splits the web application, into model, view, and controller. The view is the user interface. This is still the same since Java. The model has changed a little bit. In our context, it is database access and business logic. I would even generalize that to say data access, stored data access. Databases, the file system of the server, I would even include the session in this category, right? Anytime you are going somewhere else for data, that's a model thing, right? One of the things that you're going to be marked on for assignment 4 is, are you respecting this distinction, right? Controller is primarily the communication layer between the model and the view. I would add one more thing to that: the model, the view, and the client, right? The controller is what receives the incoming request packet. It selects what model functions are necessary based on the packet it has received, and it selects what view is appropriate based on what the model has told it. So, for example, if your incoming packet is a login request, the model function accesses the database, retrieves the password, and attempts to verify the password versus what was given by the user. That will return success or failure. We select a different view based on whether login succeeded or not. But the selection is up to the controller, not the model. All the model is responsible for is saying login succeeded or login failed. It doesn't care what happens past that point. We are talking about a separation of concerns. We are decomposing the problem. Does that make sense? Question?
So if it was trying to log in and it was gonna be successful or fail, it would pass like true or false and not care about anything beyond that. It
Yes.
would pass true or false to controller, and then the controller would decide what to do with true or false.
Yes. In the case of the very simple one, like the very simple application that we were just looking at, that true or false would be fed into like one if statement that would select between the index page or the dashboard page, right? But of course, a real application becomes many orders of magnitude more complicated than that. Question?
So the example we gave,
Mm-hmm.
the example we did for the login and registration, the model and controller were the same.
That's right. This is the reason that I led with that example, right? The password verification system that we just saw is a PHP classic kind of app architecture, right? When we want a login operation, we call login.php. When we want to register, it's register.php. The way things change for this, everything feeds into the controller, right? So the controller receives all incoming packets. It then decides what to do with them. But you have a single point of entry for the web application, and you have, like, because of the way that HTTP works, that's also your single point of exit, right? The return, the packet produced by the controller is the packet that's pushed out and returned to the client, right? But it composes that packet by including view files in itself. Does that make sense?
I couldn't.
Give it time. we've got a few slides on it, so it's not essential to get all of the details just yet. Did you have a question? No? So good. But we're making progress, right? This is a much better architecture. So, in general, packets arrive at the controller requests an update or requests some model functions to be executed. The model notifies the controller of the output of those model functions, right? Boolean checks. Sometimes we're retrieving data for viewing in the view. For example, consider a social media account, right? Maybe what you want to view is posts, right? You would retrieve your posts in the model. The controller passes those posts down to the view, and the view constructs the web page that is used to view the posts. Does that make sense? The information which comes from the model updates the view, or I prefer the term populate. We're populating the view with data. That is then returned to the controller and pushed out to the client as our response. Make sense? So, developers specialized towards front end can modify files without impacting business logic. This is one advantage, right? So, while it's true that we're sort of training you to be full stack developers, it's still very much true that people have their specialties, right? If your specialty is client-side development, it's actually quite possible that you should be nowhere near the security code, right? And I'm not trying to be